Alright, so today we're working on a 3115 board that has no brain, or technical term I guess, no CPU, which means you turn it on, you just get a black screen. Very often happens after liquid damage, and for some reason the 3115 no vcore is more common than with almost every other Apple board. So the first thing I do if I turn it on and I get no brain is I measure the vcore right here. Right, come on, there we go. See? Okay, it's either this one or this one, I forget. You'll see, you'll figure it out, you know, when you get 0 on one of them. Anyway, if you have 0 volts on both of them, then you're obviously fucked. You're supposed to get between 5 to 800 millivolts, depending on what your computer is doing at the time. The other power rails for the CPU are fairly stable and usually always work. It's just that one that's troublesome. That's PP vcore SO CPU reg. Now, this chip over here is the one that controls it. So let's look up here at the screen. Okay, page up. Let's try that again. Page up. Alright. So that is this. And this is responsible for a lot of different things. But one of the main things it's responsible for that gets fucked up very easily is operating this set of transistors here that turn 12 volts, which comes in up here, into 1 volt, which comes through down here. Or 800 millivolts, 900 millivolts, 1.2 volts. So again, it depends on what your machine is doing. And also the CPU. I honestly don't even remember the exact voltage off the top of my head because all the different years use different voltages. And I've never had a case of it being tiny bit too much or a tiny bit too low. I only ever have a case of it either it's there and it works, or it's not there and it's fucked. So to be honest with you, I don't remember the exact voltage, and to be 100% honest with you, I frankly don't really care what it is. I just care that it's there. So, this is a transistor. This is actually let's So this is actually a couple of transistors in one. This thing right over here. Let's take a look on the screen. So you have 12 volts coming in through here, comes in here, and now this is ground. So what does this look like to you? Remember what we talked about voltage dividers in the earlier videos, what a voltage divider does, how it works. So what do you see? Hopefully you're starting to see a pattern here in terms of voltage dividers. So this is where the power comes in. This is the first resistor, because as I told you, a transistor is a variable resistor. It's nothing more than a resistor whose resistance changes based on an input signal. So this is one resistor whose resistance changes based on input signal, C, U gate 1, and this is another resistor whose resistance changes based on input signal, C, L gate 1, so you have one gate and another gate voltage. So these are actually two transistors that are being used in a voltage divider. Now, what I told you a voltage divider does, a voltage divider takes a higher voltage and turns it into a lower voltage by having one resistor go between the higher voltage, which is the 12 volts up here. It's going between the higher voltage and where you want it the power to go. And then from where you want the power to go to ground, you'll have another resistor. And the value of those resistors is what will create your end voltage. So here you're starting with 12. Here's ground, and over here you won't have a voltage of something like 1. And that's what happens between these two. So what I'll often check is whether there's an input signal going to the L gate and U gate. Again, most of the time this 12 volts here is totally fine. This is virtually never short into ground. Look at this transistor. Good luck killing this thing. Look at how fucking huge it is. That's a monster. So what usually happens is that little Max chip that I'm going to point out to in a minute doesn't put out these two signals. So these signals are what you need to open this so that this shit actually starts working. See, open this transistor and open this transistor. As I said, that's two transistors in one package. And if those two don't open, you're kind of fucked. So on this board, looked up here. Let's find out where that is. Okay, so this is that chip that I showed you on the previous page earlier. And when you look really closely, you may find a hint. Let's see if you see the hint as to what doesn't work. See how there's a red thing over there?
Now there was a red thing over here, but it's now covered by solder. A lot of these liquid damage boards, you're going to see little points that are red, like all these little points in the board. When I say points, I mean these little circles. These are called probe points. Probe points are points that correspond to a lead on a chip or a lead on any one of these components here where you can actually go and measure. And anytime the board gets liquid damaged or power goes where it's not supposed to, you'll see these turn red or they'll just be blown off the board completely. So there was a huge red probe point right leading to this resistor here. And I'll show you what that resistor is on the schematic. I decided to measure that resistor, and when I measured that resistor, instead of getting the 150 kilo ohms that this thing said I was supposed to, I got something like, I believe, infinity. Infinity is not what I'm looking for here. Oh. Now when I did measure that, instead of getting the 150 kilo ohms that I was supposed to get, I was getting something like infinity ohms, which is no good. So this here is this is the resistor right here. Now this was going from the 12 volts that powers that transistor that eventually powers the CPU to this pin CPU inf toner. Honestly, I don't know what that does. I'd have to find the data sheet for the chip to see what that does. I don't know what it does. And did I care to look it up? No. Did I decide to take a class to figure out what it does? Not really. And it says that the resistor is supposed to be 150 kilo ohms. I measured it, it's infinity. I took a resistor off of another motherboard, I put it there, and now when I turn it on, I'll show you what I get. Again, a lot of the times people go, how do you know all this? Where'd you learn all this? What do you like? What am I supposed? How am I supposed to know what all this means? And do you really want to know what all of it means? Do you really want to know what every single word in the schematic means? Or do you want to just simply get a basic understanding of it and use your brain just enough that you can turn a 17-cent resistor into $200 to $400? Me personally, I chose the second. Again, it's great if I can learn what all that is. It's really great if I can learn every single every single exact thing. But again, I am aiming to learn enough that I can get paid. And I realize realistically that I would probably have to spend a lot of time in college, good 6, 7, 8, 9 years to know exactly what every single one of those things mean just by looking at it. And part of what makes this so unmanageable for so many people is that they think they actually have to know what all that means, and then they overwhelm themselves with all this information as if they need to know what all of that means in order to do something. And that's not how it works. You should just break it down into something more simplistic, something more manageable that you can understand. And when you do that, it becomes easier. And then you actually do get a chance to learn everything as you go. You do get a chance to learn each step of the way, because instead of trying to learn everything at once, you're learning exactly what you need to learn. And as you go, you've learned the last thing because you figured it out on your own. And it slowly becomes manageable, and it slowly becomes something that you can feasibly do. All you gotta do is use your brain. Yeah, come on. Don't have a heatsink on, but this is a Haswell, so I can keep this on for quite a good amount of time before anything bad even begins to happen. But I'm not going to keep it on that long. I'm just going to keep it on long enough to figure out which one of these probe points you touch to get vcore. Here we go. Alright, so as you can see, got my vcore. Let me show you what probe point I'm touching. Yeah, if you turn it on and it has no brain, check there. Again, this is different for every motherboard, and your problem may not be the same as mine. You may have a totally different problem. It may be caused by something else altogether. The last one that I had to work on that had no brain, no CPU, it was actually a little easier because there was a bunch of red crap right here, and this probe point was very, very red. I'm not looking at the right thing, am I? No, I'm not. Here we go. So this probe point here was very red, and it just gave me a hint. And I thought, let me measure that. And then I looked up what it was on here, and then I looked up what it was supposed to be, and then I noticed I wasn't getting anything, and I just followed along, and I eventually replaced this IC. On this one, I just reflowed the solder around it because this was actually a fine chip. It just had nasty looking solder. But on the other one, I actually had to replace this thing. But yeah, that's pretty much it. You know, not an exciting board, no wires. It was fairly quick and simple.